Hello, Algebra 2 students. This is Miss Huss. I hope you all are doing well this week. We are going to start off here with some simplifying of rational fractions. We're going to put to the use a few of those exponent skills that you learned and a lot of those factoring skills that you learned last week. So if you are behind on some of those things from the last couple of weeks, you might try to go do a couple of those videos, at least watch through the video piece of it before you kind of do this. But if you're feeling confident on factoring and you are just wanting to jump in here, we're happy to have you do that as well. So you're going to need to either print off the notes that are linked in Classroom with today's assignment, or if you don't have access to a printer, totally fine, grab yourself some paper and pencil. And we're going to get started here. So this first problem is going to introduce us to the idea here of equivalent expressions and the idea of sort of what could equal 1. So over on the side here, it's talking about Mr. Wonder, and it says that Mr. Wonder claims that anything divided by itself equals 1 as long as you do not divide by 0. And so there's these questions that we're going to kind of talk through here. The first one says, Mr. Wonder states that 16x over 16x equals 1 if x is not 0. First, is he correct? So if you think about to yourself, 16 divided by 16, that's 1. And any other x divided by x, if you use the quotient rule or you think about what we did with exponents, that should also equal 1. So he is correct. The next piece is that if x is not 0. So the question is, why can't x equal 0? And so if I think about the denominator of the fraction there, the denominator is 16x. And so if x was 0, then that 16x would be 16 times 0, and that would be 0. And in a fraction, you may have learned before that when you're dividing, you can't divide by 0 because you can't divide a whole number of things into 0 groups. It's not possible. And so since we can't divide by 0, then that x can't equal 0. Next, he considers x minus 3 over x minus 3. And it says, does this equal 1? What value of x must be excluded in this fraction? So again, you've got the same expression in the numerator and the denominator, and so that fraction is going to equal 1. I'm going to draw a giant 1 around that. No matter what I plugged in for x, I'd end up with the same thing on the top and the bottom. For example, if x was 4, I would have 4 minus 3 over 4 minus 3, which would be 1 over 1, and that equals 1. And that's going to be true no matter what we put in for x. However, just the same reason that we didn't want 0 in the denominator before, we don't want 0 in the denominator now either. And so I have to think to myself, what value of x would make that denominator, which is x minus 3, equal to 0? So what x value would I plug in there that would make that denominator equal 0? Well, if I was to solve that equation, I would add 3 to both sides. You could do it that way, and x can't be 3. Or you could think to yourself, okay, what number minus 3 equals 0? And that would be a positive 3. You're going to create your own rational expression or algebraic fraction that equals 1. So you can write anything you want. Go ahead and pause the video and write anything you want that equals 1. There are lots of correct things here. As long as the top and the bottom are exactly the same, you're going to have a correct answer here. So algebraic fraction means it has some sort of variable in it. So I'm just going to put a couple of examples here. Negative 2x over negative 2x. X plus 1 over x plus 1. 14x minus 2 over 14x minus 2. X to the 4th over x to the 4th. Any fraction that has an x or a y or a j or an m or whatever that's the same on the top and the bottom is going to equal 1. Then part E says, Mr. Wonder also says that when you multiply any number by 1, the number stays the same. For example, he says that the product below equals x over y. Is he correct? So you're going to see there that z over z has that giant 1 drawn around it as well. So I'm really asking myself, any number times 1, does that number stay the same? So, like if I do 1 times 4, that equals 4. If I do 1 times negative 10, that's negative 10. And if I do 1 times 19,000, that's 19,000. So yes, any number times 1 is just itself. And so here, even though I've got those z's, if I multiply x over y times just z over z, which is 1, that's going to equal itself. Basically, you can think about this as canceling out those z's because they're equal to 1. So then it says, so under what circumstances can we simplify by eliminating a giant 1? And those circumstances would be when entire terms or factors are multiplying. Okay, so when the giant 1 is something that's touching another factor or set of terms by multiplication, that's when you can eliminate it. Okay? All right, we're going to put those ideas to the test here. So we're going to do a whole bunch of examples together. I'm going to give you a couple to practice with. And there's going to be 2 parts here. It says, use what you know about the number 1 to simplify each expression below if possible. State any values or value of the variable that would make the denominator 0. So basically, what can't the variable in your denominator equal, because if it did, your denominator would be 0. So I'm actually going to start with the what can't x be, because you do have to do that before you do any eliminating of any variables. And so here I'm looking at x squared is in my denominator. And I only care about what's in the denominator of my fraction. I don't care about what's in the numerator. So that x squared can't equal 0, and so what that means is x can't equal 0. Okay, so that's the what can't x be. Then I'm going to simplify that expression. So x squared over x squared, well, those are the same on the top and the bottom. So as you know, anything that's the same on the top and the bottom would equal 1. So I drew a giant 1 around that. Okay, in the next problem, I'm going to again start with the what can't x be. So I've got x over x times x over x times x over 3. In my denominator, I've got an x, and I've got a 3. And that 3 cannot equal 0. Okay, the 3 is just the number 3. So basically here I just have x can't equal 0 again. Then I'm going to look for any giant 1s. Notice that all 3 of these terms are touching with multiplication. Okay, and so that means that I'm good to go to eliminate if I have some giant 1s. So I'm going to draw a giant 1 around both sets of x over x. And what I'm left with is just x over 3. So my solution here is x over 3 with the special condition that x cannot equal 0. Okay? All right. In part C, if you go ahead and flip your paper over, there are 2 things in the denominator here, x plus 3 and x minus 6. So you're going to either solve both of those equations to get x by itself, or you're going to think to yourself, what values of x would make those 0? Okay, and so on the first one, I would either think about this as subtracting 3 from both sides, or negative 3 plus 3 would be 0. So x is not allowed to equal negative 3. And in the second one, you would either add 6 to both sides, or 6 minus 6 would equal 0, so therefore x is not allowed to be 6. That's just the conditions on my answer. Now I'm going to simplify and get rid of any giant 1s. You're going to see me get lazy here. I'm going to start to just draw boxes instead of giant 1s. And so I draw a 1 or a box around those x plus 3s. Notice that I'm allowed to cross that whole thing off because it's touching the second fraction with multiplication. I'm having a hard time here, but you see that multiplication symbol? I cannot cross off those x's because those are touching subtraction symbols. I'm not allowed to cross off and eliminate a giant 1 that way. Only if the whole factor is touching with multiplication. Okay, so my answer here is x minus 3 over x minus 6 with the condition on my answer that x can't be negative 3 or positive 6. Okay, good. I'm going to have you try part D. It's the similar idea to what we just did, except now we've just got one big old fraction. You're going to start with the what can't x be. Now, I'm going to start here with not x this time, m plus 6 cannot equal 0. So think to yourself, what value of m would make that whole expression equal 0? And hopefully you came up with that m cannot equal negative 6. Now, the next one's a little bit trickier. Okay, so you might be thinking you can do some of this in your head, but when you have a coefficient on your x or your m that's not just a 1, that's when you've got to do sort of 2 steps here. So you're thinking, what value of m would make 3m plus 1 equal 0? So I'm going to solve this like a normal equation. I'm going to start by subtracting 1 from both sides, and then I'm going to get rid of that 3 by dividing both sides by 3. And I'm actually going to leave my answer as a fraction, but you can go ahead and change that to a decimal if you would like. So the 2 things that would make my denominator 0 would be negative 6 and negative 1/3. And then what you're going to do is you're going to make a giant 1 out of your entire factors that are touching by multiplication. And so I can do that with that m plus 6 and m plus 6. and I'm just left with 2m minus 5 over 3m plus 1 as my answer. Okay, on the next one, the only thing on the bottom that could equal 0, you've got a 4 and you've got an x plus 7. The only thing there that could equal 0 would be x plus 7, and so I start here with wondering to myself, what value of x would make x plus 7 equal 0? I don't want that, and so I solve that, and I get x cannot equal negative 7. I'm actually going to really quickly write this problem expanded out. And so the x plus 7 to the 4th on top means that I have 4 sets of x plus 7. The x plus 7 squared on the bottom means that I have 2 sets of x plus 7. And now I'm just going to cross off everything I can and simplify. So first things first is I can cross off 2 of those sets of x plus 7. I'm left with 2 on the top. And then 12 and 4, I'm going to ask myself, can I simplify 12 over 4? Well, 12 divided by 4 is just 3. And so I have a 3 and then 2 sets of x plus 7. All right, let's keep trekking through here. We're going to simplify and what can't x be for these last 3 problems, and then you're going to get a chance to practice, and that'll be that. So you're going to write the 2 things that x cannot be here. So basically, what would make both of those equal 0? So pause real quick and solve both of those equations for x. We don't want zeros in the denominator. And you should end up here with, if you add 1 and then divide by 4, you should end up with x cannot equal 1/4. And then on the next one, you would subtract 3 and then divide by negative 2. A negative divided by a negative gives me a positive 3 over 2. And again, feel free to turn those into decimals, would be 0.25 or positive 1.5 would be acceptable answers as well. Then I'm going to make a giant 1 out of those 3 minus 2x's, and I'm only left with a 4x minus 1, but I'm going to ask myself, am I left with that 4x minus 1 in the numerator of my fraction or in the denominator? And I'm left with it in the denominator. And so I actually have that giant 1 is left on top. So my answer here is 1 over 4x minus 1. Okay, problem G. You're going to start with the denominator, and you're going to ask yourself, okay, what would make 3x plus 6 equal to 0? We don't want that in the denominator. So you're going to subtract 6 and divide by 3, and that means that x cannot equal negative 2. Okay, now, you've got a little bit of a tricky situation here, because right now all of my terms are touching by addition, right? There's additions between them, and it kind of looks right now like there's nothing that I can simplify there. So I'm going to try to factor if I can. Now, I'm not going to do a box and diamond. I'm going to try to take out a greatest common factor. So we practiced that last week. So you're going to look at the numerator, and you're going to ask yourself, okay, so 4x squared and 8x. What's the greatest common factor that I could take out of both of those? And I can pull not just a 4 out of 4 and 8, but I can also take an x out of both of those terms. So I'm going to pull a 4x out to the front. If I take a 4x out of 4x squared, okay, I've taken the 4 out and I've taken one of 2 x's, and so I just have an x left there. If I take a 4x out of 8x, I divide 8 by 4 and I take that x out and I just have a 2 left. Okay, same thing on the bottom. You're going to look for a greatest common factor that you can take out of the 3x plus 6. And the biggest thing I can divide both of those by is a 3. That 6 doesn't have an x to give, so I can't take an x out, just the number 3. And if I take 3 out of 3x, I have just an x. If I take 3 out of 6, I have a 2. And then what happens is those x plus 2 and x plus 2 make a giant 1 that I can eliminate, and I'm left with just 4x over 3. Okay, now part H is kind of a pain. Before we can even do the what can't x be, we're going to have to factor both the top and the bottom. For the sake of time, I'm going to do the box and diamond for the top, and I'm going to have you pause and do the box and diamond for the bottom. So if I were to factor with a box and diamond, putting a 0x in the middle, because there's no x's in this problem, a box and diamond would give me x plus 4 and x minus 4. I'm going to have you pause and factor the denominator, that x squared plus 9x plus 20. And using your factoring skills from last week, hopefully following this sort of box and diamond, you ended up with, and go ahead and pause and look through that work if you got lost, but hopefully you ended up with x plus 4 and x plus 5. Now before I simplify anything, I'm going to take those factors from my denominator and decide what x can't be. So x plus 4 can't equal 0 and x plus 5 can't equal 0. And if I were to solve both of those, x can't be negative 4 and x can't be negative 5. And then I'm going to simplify my answer, getting rid of my giant 1 of those x plus 4s, and my answer is just x minus 4 over x plus 5, with the condition of the two things that x can't be. Okay? You're going to give this a shot. If you're feeling overwhelmed, I totally understand. Just do your very best here. You are going to answer the questions, simplifying and telling me what can't x be, what would give you zeros in the denominator. Sometimes here you're going to have to factor, like on B here you're going to have to do greatest common factor on the bottom, find that, and on C for the denominator you're going to have to do a box and a diamond to factor that. So you're going to pause, you're going to answer through the questions, and then so quickly I'm going to throw the answers on here so you can check what you did. Okay, so x can't equal 5 on the first one. You made a giant 1 and you were left with just an x as your answer. On B, you had to find that x couldn't be negative 1 over 4 or negative 3 over 12 or negative 0.25. Those are all fine answers if you wrote that, or negative 0.25, that's fine as well. And then you had to pull out a greatest common factor on the bottom, and that greatest common factor is 3. And then you can make a giant 1 out of those 3's, and I'm left with just 4x plus 1 on the bottom. On part C, before you could tell me what x couldn't be, you had to do a box and a diamond. And you're seeing that happen super, super fast. But you end up with x minus 9 and x plus 3, which means that x can't equal 9 or negative 3, because that would give you zeros on the bottom. And when you make a giant 1 out of your x plus 3's, you're left with x plus 4 over x minus 9. You're going to do just a little bit more work with this tomorrow. We're going to introduce a little bit of multiplying and dividing, but it won't change a whole lot of the process for you, honestly. And then you'll get a chance to practice on Wednesday or on Thursday this week. All right. I hope you have a good rest of your day. Thinking about you all. Bye.